Find the general solution to the ODE y double prime minus y equals 0. And so as usual, it's constant coefficients. We're going to guess that y is some e to the rx, where r is a constant. All right, so then we're just going to plug that in. So if y equals e to the rx, y prime equals r e to the rx, y double prime equals r squared e to the rx. And we're going to plug that into the difference equations. So we have y double prime minus y equals 0. So that's r squared e to the rx minus e to the rx equals 0. I'm going to go ahead and factor out the e to the rx. So we get r squared minus 1 e to the rx equals 0. And right, e to the rx, we can't set r equal to a number to get the e to the rx term to disappear. So we got to focus on this polynomial here in r. And there are two solutions to that factors into r plus 1 and r minus 1. And then that's times e to the rx equals 0. And so the r equals, plus or minus 1 should solve the ODE. And so that would mean we have actually two different solutions here. So we have y1 of x is equal to e to the x, and another solution, y2 of x equals e to the negative x, right? 1 times x from the r equals 1, and negative 1 times x for the r equals negative 1. Let's just go ahead and see, why that works. So let's go ahead and plug them in. So I want to look at, y1 double prime minus y1. Well, okay, we plug that in. First I have to compute y1 double prime. So let me go ahead and do that. So, well, we can do it here. So take one derivative, still e to the x. Take a second derivative, still e to the x. So this ends up just being e to the x minus e to the x. And yeah, that definitely equals 0. So that actually solved the original difference equation. Well, what about y2? Well, y2, I'm going to actually write out the derivatives here. So I have y2 equals e to the negative x. I've got y2 prime equals negative e to the negative x, from the negative x popping down and becoming negative 1. And then y2 double prime, well, I pop down another negative, so I get negative negative. That's positive, so e to the negative x. And if you plug that in, y2 double prime minus y2, well, that's e to the negative x, right? And then minus e to the negative x. And yeah, that's definitely 0. So yeah, those two things solve the difference equation. And then to get the general solution, we actually have to take any combination of them. And we'll see that in the next videos. Because to solve initial value problems, we actually need two functions. So the general solution is y equals c1 y1 plus c2 y2, where c1 and y1 are kind of like constants of integration. You pick them to be whatever they need to be to solve an initial value problem. So in this case, then y of x, the general solution, is c1 e to the x plus c2 e to the negative x. And that's the general solution to this second order ODE.